Hey there, I'm again back, and today the questions that we are going to solve is completely related to the radius of convergence. And here, the question that appears before you on the screen is: let f be the rational function of complex variable given by f of z equals to z cube plus 2z minus 4 by z. The radius of convergence of the Taylor series of f at z equals to 1 is the options that appears before us is option A is 0, option B is 1, option C is 3, and option D is infinity. Now, when we just look at the function f of z that is given for us, f of z is equals to z cube plus 2z minus 4 by z. Now, when we just equate the denominator to 0, so this is z equals to 0, you see that z equals to 0 is the only pole that this function has. Now, if we let R, capital R, to be the radius of convergence of the Taylor series of f, then z naught about z naught equals to 1, then R is equal to the distance between the point z naught equals to 1 and the nearest singularity. And the nearest singularity, that is the pole of order 1 that we have, is z equals to 0. And the distance between z naught equals to 1 to z equals to 0 is 1. Therefore, R equals to 1. And if we just get back to the options, you see that the option B is having the same solution. That is, B equals to 1 is the right answer for this problem. But if we intend to calculate the circle of convergence, then for this Taylor series of f about z equals to 1, it is modulus of z minus 1 is equals to 1. And therefore, the circle of convergence, that is the circle with center at 1, this is the circle with center at 1, and it is of radius of how many units? It is of radius 1 unit. And this is the circle of convergence for this. And thus, we are done with the question. Now, the other question that we have is that let R denote the radius of convergence of the power series summation k equals to 1 to infinity k into x power k. Then the options that appear before us is R greater than 0 and the series is convergent on the closed interval minus R comma R. Option B is R is greater than 0 and the series is convergent at x equals to minus R, but does not converge at x equals to R. And option C is R is greater than 0 and the series does not converge outside the open interval minus R comma R. And the final and last option given for us is R equals to 0. So what we have is that summation k equals to 1 to infinity ck x power k. And here, instead of ck, what we have is that it is the k we have. So we apply the ratio test to it. And by applying the ratio test, the radius of convergence of the power series can be it can be computed by this formula. Right, so we try to apply the ratio test, and according to it, R is equals to limit R tends to infinity Cn by Cn plus 1. That's the formula that we know. And here we have Cn as n. So this is limit when n tends to infinity, n by n plus 1. And this is, we can just write down this fraction as 1 by 1 plus 1 over n. And this 1 over n is equals to 0. So this is because n is tending to infinity. So therefore, this is 1 by 1 plus 0, and this is equals to 1. Hence, R equals to 1 is the radius of convergence of the power series. Now, by the definition of the radius of convergence, the power series converges if modulus of x is less than R and this R is equals to 1. And that is x belongs to minus R comma R. This is equals to minus 1 comma 1. And this series diverges for this modulus of x when it is greater than R is equals to 1. Now, therefore, we come across with the two cases. Now, what are the cases? The first case that we come across is that x is equals to R is equals to 1. Let's see what happens with this. Summation k equals to 1 to infinity ck 1 to the power of k. And as you all know that ck is equals to k. So therefore, summation k equals to 1 to infinity k and 1 to the power of k. Now, what is this? This is equals to summation k equals to 1 to infinity, that is k. Now, by the test of a divergence, we have limit when n tends to infinity, Cn is equals to limit n tends to infinity n, and this is equals to infinity, which is not equals to 0. And therefore, the given power series does not exist for x equals to r is equals to 1. Now, we go with the other case. The other case is that x is equals to minus r, and that is equals to minus 1. Let's see what happens with this. Now we have the same summation k equals to 1 to infinity ck minus 1 power k. This is equals to summation k equals to 1 to infinity k into minus 1 to the power of k. Now we apply Leibniz test of convergence of an alternating series, and with this we have limit when n tends to infinity modulus of Cn is equals to limit when n tends to infinity Cn. This is equals to infinity, which is not equals to 0. Therefore, the given power series does not converge for x equals to minus r equals to minus 1. And hence the option C, that is what I believe here. If we go back to the options, here you see that option C, r is greater than 0 and the series does not converge outside minus r comma r. I think that this is with all the application of the test, we see that option C is the right solution. That is, r is greater than 0 and the radius does not converge outside minus r comma r. So these are the two questions for today, completely related to the radius of convergence. Thank you. Thank you. And for watching this um, problem, and I hope that you all will subscribe my channel, and hope to see you again with a nice problem related to the CSIR net. And one more thing I would like to say all the viewers that the questions that I solve here in my channel, they are not only helpful for the students who are preparing for CSIR net, but also for the students who are MSc postgraduate with mathematics and mathematics as a major subject, and then who are preparing for the GATE. So the questions are all very helpful for GATE students as well as for the CSIR net. Thank you. Thank you so much for watching.